So, what is Temponest? In simple terms, it is a plugin for Tempo2 that was written by Lindley Lintardi and a few others back in 2014. I'm not really going to go into the mathematics behind it. If you want to learn more about that, I recommend reading the paper, which is the archive link there. And if you do actually want to download Temponest and install it on your computer, which I do not recommend doing, you can pull it from the GitHub repo. However, it is, as Aditya mentioned earlier, it is not actually under active development currently, although we are starting to sort of figure out how it works under the hood. So as I said, it's a plugin for Tempo2. So in order to run Temponest, you need Tempo2. And the way you actually run it is you effectively run this command here, which you run your Tempo2. When you specify your plugin, you say Temponest. You pass it this flag, -f. Then you give it your ephemeris file, so your timing model, which we tend to just call it a par file, as well as the TOAs and the TIM file. And then the last thing you do is you specify this thing, which is your configuration file. And this configuration file is essentially tells Temponest what to do. So it tells it which stochastic parameters to search over, and whether you want to also search over any of the deterministic properties of the pulsars that you're looking at. And as Aditya said, it uses this. It's not really a Markov chain Monte Carlo sampling method. It's what's known as a nested sampling algorithm. In this case, it uses multi-nest, which is you can read more about in this paper by Feroz et al. In 2009. It also uses a different nested sampling algorithm called polychord. However, you do need to configure Temponest in a way to get it to run that. And I don't think we've actually managed to figure out how to do that yet. Again, this is all written by one person or a very small group of people. It's very poorly documented. Hopefully, in the future, we'll have some better documentation for you.
I have one question.
Yep.
So this multi-nest and polychord ultimately does the same thing, right?
Essentially, yes. There's some subtleties in terms of how they do the nested sampling.
So is it are they just used simultaneously, or one is used and the other is not used?
It's one or the other.
Okay.
So you either use multi-nest or you use polychord. Yeah. So what can we actually do with Temponest? As Aditya mentioned in his talk, the idea behind Temponest is you're able behind using Temponest, and its advantage over Enterprise at the moment is that you can simultaneously sample both of your deterministic and stochastic pulsar parameters. This allows you to actually make what are referred to as unbiased measurements of the pulsar properties. So for instance, if you were to imagine your pulsar timing residuals, you can have a signature in your timing residuals which you may interpret as being, I guess, a second order spin frequency derivative, which looks like a cubic polynomial. However, that same signature can actually be due to just simply a red timing noise process. So when you're able to actually simultaneously model both of these two properties of the pulsar, you can actually try to infer a true unbiased measurement of this second order spin frequency derivative. And of course, it also allows you to understand the noise processes that govern the timing noise in pulsars. And something that I've been working on myself is looking at how this timing noise varies across the pulsar population, and whether you can find correlations between particular pulsar properties and the strength of the timing noise, and so on. And of course, you can do this thing called Bayesian model selection, which involves using the Bayesian evidence. So Temponest is fantastic for doing this because it uses nested sampling. Nested samplers work by not necessarily calculating the posterior probability first, from which you would then need to calculate the evidence from. It instead works the other way around. So nested samplers calculate the evidence, and then from that calculation of the evidence, you can then draw posterior samples from. So when you actually finish your Temponest run, you end up with a final evidence for this particular model straight away. You don't have to do any complicated thermodynamic integration to end up with your calculation of the evidence. And of course, you would want to do this in terms of if you have multiple models, or you might say for example, you think that there is a particular signal in your timing residuals, and you want to compare that with a simpler model where you're just analyzing the timing noise itself. So you can actually use this to try and see whether you have really measured really actually detected a particular signature in your timing residuals. So as an example of running Temponest, this here is a pulsar that we observe quite regularly at the Molonglo Observatory Synthesis Telescope. This is a telescope in kind of southeast Australia. If you come to my talk next week, I'll be telling you about the pulsar timing program of this telescope. So this is a pulsar called 1644 minus 4559. You can see that it has this very strong low frequency structure in its timing residuals. So it's actually dominated by these, the timing residuals are dominated by this red process. I don't remember exactly what the spin period of the pulsar is, but this is actually, the actual variation due to this red noise process actually spans multiple pulse periods. So there's actually in order to actually get get the best results out of Temponest and even Tempo2, you do actually need to keep track of the pulse numbers, the actual pulse. You need to have what's known as a phase-connected solution, and indeed you need to actually make sure that you know exactly which pulse has occurred when throughout your data set. So I'll be showing you how to do that with Tempo2 as part of this Temponest activity after the break. So we have this pulsar, and we run Temponest on it. So the first thing we do, first off we run Tempo2 to try and measure its spin frequency given by nu, and its spin down frequency given by nu dot. So you can see that Tempo2 is claiming that you can measure this spin frequency down to, I think it's the 12th decimal place. The number that's in a bracket is simply just the uncertainty on the final digit for those numbers. And the claim is that Tempo2 is claiming that you can measure these parameters quite well without actually accounting for your timing noise model, and without actually accounting for the timing noise itself. So we run Temponest, and we end up with this plot here, which is known as it's either known as a corner or a triangle plot. So can people raise their hands if they actually understand what this plot is showing? Okay, or if you have actually seen these plots before. Okay, because the first time I saw these kinds of plots, I had no idea what was going on. And I didn't actually really truly understand the kind of beauty of what they actually represent. So in these kind of histograms on the diagonal, these are the one-dimensional marginalized posterior distributions for each of these individual parameters on either the x-axis or the y-axis. These plots that are in the squares show these what are referred to as two-dimensional posterior distributions. So they represent the amount of they represent both the posterior samples for those two particular parameters that are being compared, as well as sort of graphically representing the amount of correlation that exists between these two parameters. So for instance, I might just use my mouse for this. You can see that the spin and the spin down of the pulsar are extremely correlated with one another. Yeah. Which means that this in a sense means that any measurement of your spin down will also is also strongly dependent on your measurement of the pulsar spin itself. Luckily, these stochastic parameters given by this log amplitude and spectral index beta are not particularly correlated with the spin and the spin down in this case, but in other cases they can be. So the gist of this plot is showing that, so we've run our Temponest analysis, and we get out our measurements from Temponest for the spin and the spin down. Again, the sort of plus and minus values here are just the error on the last digit in these numbers. And the first obvious thing to note is that these two numbers, for example, for the spin down that you get from Temponest and Tempo2 actually disagree. In fact, the value that Temponest returns actually lies outside. So these numbers are the 95% confidence intervals. It lies outside of the 95% confidence intervals that we get from Temponest. Meaning that because we haven't actually taken into account the timing noise in this particular pulsar, we've ended up with what is potentially a biased measurement of the spin down of the pulsar. And I think there's a similar, but I guess to a lesser extent, similar effect, but to a lesser extent with the pulsar spin frequency. Yes?
Sorry, so is the tempo 2 a biased measurement because the timing noise wasn't taken out?
Yes. So in the tempo 2 measurement, because you haven't accounted for your timing noise, you can end up absorbing some of the actual timing noise into your measurement of particular pulsar properties. And in addition, it can also lead to underestimating your uncertainty on that factor as well. Yeah.
So in that case, like something like 1644 has a strong double dot term, which in tempo 2, if you model that, then you are accounting for some of the timing noise.
Yes. Yeah.
And then I don't know that there'd be such a discrepancy.
Yeah. So.
Isn't this just because you haven't actually modeled your parameters properly, and you can see in tempo 2 from that plot that you have higher orders, so you're not doing tempo 2 correctly?
So that's one possibility. However, and I will actually, I think in the activity we'll be going over this. This sort of cubic, sort of polynomial curve that you can see here, you could model that as an F2 or a second order spin frequency derivative. But that might not actually be a true measurement of the second order spin frequency derivative. It could just be you're effectively what you're measuring as your F2 term is in fact just your red noise. Yeah. So while you might actually end up with a slightly better measurement of the spin and the spin down, you might not your measurement of F2 is not necessarily correct.
Yeah, no, I would.
Yeah.
But if you're trying to measure
If you're trying to measure F2,
if you're trying to measure F0 to F1,
yes.
then you need to take that.
Yeah.
I was curious that so far this kind of pulsars, those are very strong timing lines. Suppose if I want to make some every 15-day ephemeris for the pulsar, then if I get the solution from this 15-day ephemeris in tempo 2 and if I do it from Temponest, how much do they show a significant difference in that? Because since the timing noise is over a large time scale, I mean 15 days, the pattern for the timing noise.
Yeah. So if you were to split this up into, I guess, smaller 15-day, 15 or 30-day segments, you could get local fits for, say, the spin or the spin down. But the issue then is when you want to then, I guess, use that local fit for another data set that you've taken at a completely different time. And in that case, the spin may have wandered a bit, and so when you actually go to applying that timing model to your new data, you will end up seeing some sort of trend in your data. So you might say, oh, okay, I've actually gotten the spin period incorrect, or the spin down incorrect. So there'll be slight differences in your measure or what you think the spin period is at these different times, due to the spin noise, or due to not accounting for the spin noise. Does that make sense?
Well, we can take it up.
Okay.
Later, maybe.
Right. Yeah. So I guess after lunch we'll be going on to this activity, which is I'll be showing you how to use Temponest to essentially look for a bunch of signals that Aditya and I have injected into a a bunch of simulated TOAs that have very strong red noise. So, of course, the activity name is hidden in the noise. So if you have pulled the latest version of the Docker, you can clone our Bitbucket repository from. I didn't realize I had my username in that. Anyways, you can clone the Bitbucket repository from this link. I think that works. Is that going to work, Aditya? Yeah. Anyway, so the point of it is that we've basically given you the timing models and TOAs for 4 different pulsars, and we'll be sort of going through showing you, trying to see if there is any sort of additional signals hidden away underneath the timing noise of these in these pulsars. We're showing you how to sample not only the red noise and white noise parameters, but also include these additional pulsar properties in your parameter estimation. And if we have time, we can actually then try running some model selection to determine if you are actually in fact seeing the effects of, say, a proper motion or an F2 term versus just a pure red noise model. So, yeah. If there's any more questions, yeah.
So after fitting with the Temponest, then what was the residual?
Sorry.
First you stored the residual, right?
Yep.
And it was with only Tempo 2.
Yes.
After that you fitted with Temponest. Then how the residual was better than this?
So you can actually. So once Temponest finishes its run, it does actually it actually outputs a new ephemeris file, and that actually does include these terms that describe the timing noise. So you can then open up this new ephemeris file in Tempo 2. You can subtract off the red noise from your timing residuals. So I think in this case, I didn't save the actual plot after you subtract it off, but I think in this pulsar, it manages to find a very good fit for the red noise, and so when you subtract off the red noise model, you effectively end up with white residuals. But unlike the more standard timing methods, you don't then go and do your searches for other parameters after you subtracted off the red noise. You're doing those searches at the same time. Okay. All right.
We are pretty much on time. Maybe should we take the last question, or people willing to dash for food? Abhishek, are we good for lunch?
Yes, but I have two quick announcements. One is that those who have written your name for related GMRT, important thing is that please make sure you have business visa, because for entering GMRT, it's a government rule that you have to have a business visa, otherwise they don't let you enter the GMRT premises. That's very important. And it's going to leave Saturday morning at 7 o'clock. I will again do the announcement 2-3 times more. And visa is a very important thing.
Okay.
Conférence visa doesn't.
Sorry?
Conférence visa.
So far in our right now in the LOC meeting, I have been asked to inform you that the government visa, the business visa only works. I'll get back to you again after asking LOC that whether it's fine. I'll give that announcement maybe the next coffee break. Sure.
Where should they meet you for the bus? They should. Whoever wants to go to GMRT on Saturday, they should come to NCRA.
Yeah, it's leave from NCRA. So because we also want to do, there are 17 seaters, so we have 16 people right now. If anyone wants to join, we can take one more person in the bus. So
So will there be transport from Pastor Guest House to here?
that LOC have not yet responded me, but since it's very early in the morning, I hope there should be. I'm still working out with that thing because we have one more day in our hand, and I'm working on that thing. But right now, the most important thing they asked me to inform is that we should have a business visa.
Can you add me to the list because I did not sign up?
Okay, I'll add you.
Thank you.
Fine. Yes, there are a few more forms that we will that one has to fill before getting before entering GMRT. But let that form come first, and then I will share it with you. It's some basic form which says that you are traveling. It's fine like that. So I'll hand over the form as soon as I get it from the admin people. That's all.
What's the second thing you wanted to announce?
Sorry.
You said you wanted to announce two things.
Yes, bus from NCRA tomorrow is going to leave a bit late because we have public lecture. So it will be leaving at 8:30 in the evening from NCRA Pfizer Guest House because the public lecture time is from 7 to 8.
And the public lecture is next to
Chandrasekhar Auditorium. Here.
not the IUCA auditorium?
Yeah, that's it.
Okay.
That's all.
I have a quick sort of announcement to make, which is I pointed in that direction because I have a couple of friends who work in the science lab, which is run by IUCA. Currently, they're not in a state to receive many guests, but they have some interesting displays on science popularization, toys for teaching young people science. If you are interested, please talk to me. I managed to find a little slot at 4 where they can receive maybe a very small group of people. If many more people are interested, I will have to talk to them to see if they can receive you sometime tomorrow or maybe Saturday if you're not going to GMRT. But yeah, today at 4, maybe less than 10 of us can drop by and take a look. So if you're interested, talk to me. And yeah, that's okay. So we meet at what's the next time? How long does lunch last?
We come back from.
Should we try to come back a little earlier? Oh no, it's 1:45. Right. No, please. sorry.
You need some time to eat.
Yeah, I must be coming across as the hardest taskmaster ever. Please enjoy your lunch, and I hope to see everyone back at 2:30. Thanks, Mark.
That's the repository that I plugged earlier and used to set that up.
Yeah, so I think it was because I was logged in and I copied the clone for
Oh.
you.
It's using your authenticated.
Yeah.
Got it.
Alright, so just leave that up there.
I'm going to adjust this. Because I'm like getting you with the camera instead of with the capture. But the camera was meant to be just getting the board. So it's like essentially adjust up there.